Good morning, everyone. Today is the 8th day of the Corona crisis, but for you, another math lesson. In this lesson, we're going to look at the second part of paragraph 9.5, which is about the sum rule. And the sum rule is basically an extra tool to calculate the amount of possibilities. Usually when I am explaining the sum rule, I'm drawing a picture, and usually that picture helps you. I also drew this in class, so if this seems familiar, that's possible. Imagine we have three cities. So that this is Oostenrijk, say that this over here is Udenhout. And over here we have Haven. Then you can think about the amount of from Oostenrijk to Udenhout. Now let's assume that there are two routes between Udenhout and Oostenrijk, and three routes between Udenhout and Haven. Then a question could be, in this case, how many routes are there from Oostenrijk to Haven? And if you've seen last video, you should immediately say 2 times 3, which means 6 different routes. But we can make this problem a bit more complicated by adding another village. So look at Oostenrijk again. Let's add Udenhout as well. Udenhout and Haven here. And for that part, nothing will change. So that means that there are still 2 routes between Oostenrijk and Udenhout. And there are 3 routes between Udenhout and Haven. But I'm going to add a 4th village. Let's do that over here. Not sure what should make sense. Let's use Haghorst as an apology to Fenne. I think she's still mad. And let's assume that there are 4 routes between Oostenrijk and Haghorst. So everyone here in Oostenrijk wants to go there. But there's only 1 route between Hagen and Haghorst. Problem is, if I want to look at the amount of routes from Oostenrijk to Hagen, I can go there with through different villages. I can go through Udenhout, but I can also go through Haghorst. So basically there are 2 options. Option 1 is from Oostenrijk to Udenhout to Hagen. And the other one is from option 2, of course. From Oostenrijk to Haghorst to Hagen. Okay. This first option is basically the problem we faced in the previous example. It's 2 times 3, which is 6 routes. Then, if we would not look at Udenhout, for example, if we don't want to go there, then we can only go through Haghorst, and then we have 4 times 1 route. The thing is, these 6 routes through Udenhout are fine, but also these 4 routes through Haghorst. That means that all of these 10 rules correct. And now you're basically using a combination between the sum rule and the multiplication rule. We're using over here is the multiplication rule. And what we're using over here, see some. And I like this example because both rules are really clear in this example, hopefully. Let's look at something which complicates things. So this example was relatively easy, but in the previous view we're also looking at codes. And I want to give you one example where we use the sum rule in an example with a code. And hopefully that also shows you why it's sometimes necessary. We're going to make codes with 4 digits. So that doesn't change. I only want to use a select few numbers. I only want to use 3, 4, 5, 6, 7, and 8. Okay, and if you want to calculate the total amount of combinations, that's easy. Because there are 6 different numbers. That means that the total amount of codes, so no restrictions, or basically no further restrictions, because we still can't use the number 2. Then we have 6 times 6 times 6 times 6, which gives you 1200. This is always dangerous to do this without a calculator. And maybe you remember them. In the last video I used slots over here because we had 4 slots in which we wanted to fill in a number. We also saw that when you had, for example, a restriction unique numbers, that meant we only wanted to use every single number once. I think in your textbook they call it with and without repetition. Do not confuse that with U2 song, with or without you. If we want to use unique numbers, then we have 6 options for the first slot. Then we have 5 options for the second one, 4 for the third, and 3 for the fourth. So if you calculate this, it's 360 combinations. Okay. Then let's make it harder. In the last video I told you we're going to look at numbers above 6,999. In this video we're going to make it more difficult. And we're going to do that as follows. I want numbers above 5,600. And at first this might seem easy because some of you probably want to do this. We're going to have 1, 2, 3, 4 options for the first number, and then 3 for the second one, and then for the other 2 it doesn't matter. But this is actually wrong. Why? It's basically because if the first number is a 5, the second number also determines how many options I have over there. Okay, what does that mean? Well, let's split this problem up into 2 different groups. Let's use not the numbers. Sorry, one thing I want to add. If you look at the number 6,345, for example, it's not included in this one as well. So we're going to do it as follows. We're going to use numbers with group 1. That's our 6,000 plus group. And our second group starts with 5. And after that we don't know what happens. It has to be above or greater than, I think I should use greater here. So 2 groups, one with numbers above 6,000 and the other one with start with a 5. And now you'll see the difference, hopefully. If you look at this first one, the first digit we have 3 options. And for the second one, we have no further restrictions. If we start with a 6, 7 or an 8, I can use all of the other numbers as much as I want. 6 times 6, 6, which is 648. For the other group, if we start with a 5, how many options do you have for the first number? 1, because you can only start with a 5. Then for the second digit, we're not allowed to start with a 3 or a 4 or a 5, because otherwise it's less than 5,600. So we only have 3 options. Then we have no further restrictions, because if we have a 5 and a 6, then I can add whatever 2 numbers, and it's always greater than 5,600. So times 6 times 6, which is 90. Sorry, 108. And now, these numbers are all correct, these numbers are all correct. None of these numbers are in each other's group, so we can add these 2 things. So in total we have 752 numbers. So once again, first we're using the multiplication rule, and after that we're using the sum rule. Good luck.